Today, I'd like to explain the very scary sounding, yet fairly essential, fundamental theorems of calculus. The first chunk of this is typically called the first fundamental theorem of calculus. To derive this theorem, we begin by looking at some red function f of x on a graph and asking, if we choose two random x values of a and b, how do we find the blue area under this curve between a and b? To figure this out, we start by remembering that the area under a function is given by taking the integral of that function with respect to x. If we specifically want to find the area between a and b, we'll note this by writing a tiny a and b on each end of the integral symbol. Intuitively, we can notice that if we take this whole green area under our entire curve from 0 to b, and we subtract away from it this yellow area under our curve between 0 and a, we are left with just the blue area between a and b. This can be written as the integral from a to b is equal to the integral from 0 to b minus the integral from 0 to a, which can also be written using the antiderivative of f, which is denoted with a capital F. And this statement here is exactly our first fundamental theorem of calculus. Now for part 2 of this theorem, usually called the second fundamental theorem of calculus. This theorem states that if you take the derivative of some function y with respect to x, and then integrate that derivative with respect to x, it will simply equal our original function y. So it's essentially claiming that derivatives and integrals are inverse operations of one another. We can easily intuit this to be true because we can interpret this statement to mean that we are finding some tiny change in y and dividing it by some tiny change in x, then multiplying that by the same tiny change in x and adding that up infinitely many times. If we are both multiplying and dividing by some tiny change in x, then they're gonna undo each other, almost like canceling each other out in a fraction. Now we're simply left with the integral of dy, which means to add up infinitely many, infinitely tiny pieces of y, which we know from my previous videos to simply equal y.